cancer. So basically there are differences, okay, between tumor and cancer. Alright, so if you're looking at the conditions or the differences between this tumor and cancer, of course both of them involve an abnormal cell division or abnormal cell growth. Alright, both of them. So basically that's going to be the similarities. Alright, so both of them is going to be an abnormal cell growth or abnormal cell divisions. The difference is that in terms of tumor and cancer is that tumor usually is going to be benign. Alright, tumor is benign or it can be malignant, but we're talking in terms of cancer. It is basically definitely is going to be malignant. So what is benign? Benign is basically a localized situation. So basically you're going to have a cell with an abnormal cell regulation, abnormal cell divisions, but it is a localized. So that's what this tumor is all about. But once the cell which undergo this abnormal cell division now influence the other cell to go into also an abnormal divisions, so then that is basically you're going to have the malignance. Malignant is basically a metastatic, meaning that the one that can spread from one cell to the next cell. So basically you're going to have the benign, and then the other one is going to have the malignant. So malignant is basically go into the systemic rather than localized. So a tumor can be may not be fatal. Okay, sometimes is not does not cause any problems. All right, does not cause any problem. Does not what do you call that? You are in any danger if you have this tumor. But of course, sometimes it can be fatal. It can be dangerous. But when you're talking in terms of cancer, then definitely it is a condition where you're going to have a problem because it is a systemic, so it is will affect the rest of the whole system. So basically. And like I said, when you're talking in terms of tumor, it can be even beneficial. I know you do not. I don't think any of you know who is this person is, the one that I put at the top here, but I'm sure you recognize at the bottom one, right? So everybody know Angelina, what is it? Angelina Jolie, right? But I don't think you know who is the person up there. That is Cindy Crawford. That is the top model during my time. Alright, so she's one of the highest paid model. Now, she became famous because of this thing. Hang on, let me. There, the mole, the light. So at this, what do you call that? So that's basically the sign point that finally put her become the top most famous early female of Islam model during my time now. So in fact, they will suggest, they try to suggest to her that remove this mole, right? Because for Caucasians, the mole can increase the risk of developing a skin cancer, right? But she said that no, that's the one that made her famous, so she kept the mole. Of course, you're going to have this Angelina Jolie, but not because of the mole, but for other things. But of course, she also has the mole, right? So the point that I'm trying to make here is that it may be fatal, but in other situations, this tumor can be beneficial, as an example of this two model or an actress, right? So because of that, we did for that photogenic for her. And like I said, both of them are condition where you're going to have a cell which is uncontrollably divided, an abnormal cell division. So that's why you're going to have this mole, because the mole is basically a cell that keeps dividing. All right, but as we saw before, that it is a localized. Okay, it is localized, so because of that, it does not disturb other physiological functions in our body. But once it's going to metastatic, or if the tumor becoming big and then start disturbing the physiological function, then it's going to be problematic. All right, it's going to be problematic. So among the difference that benign is a slow rate, all right, compared to compared to cancer, so it's a faster rate. It's not cancerous, like I said, but when you go into malignant, it's going to be a cancerous, okay? And then do not spread, and then spread is to remove. So basically, that's the difference between tumor and cancer. So when you're talking about cancer, basically it is an advanced stage of tumor. So where the tumor is really now metastasized and then spreading to the other place. And like I said, even the difference between tumor and cancerous cell is that they are all benign to begin with, and the similarity is that both of them will have these two similarities. Number one, we already discussed, or we mentioned just now, which is abnormal cell growth. When I say abnormal cell growth, meaning that it is a cell that does not know when to stop, when they start divide or producing new cell. Alright, so that's what it is abnormal cell growth. The other one is whether you're talking in terms of tumor or cancer, they have this capability of angiogenesis, meaning that they are capable of producing new blood vessels. Of course, they need this, otherwise the cell, the new cell that we develop will be starved to death, basically, because they do not have nutrients as well as oxygen. So that is the requirement that they need to be able to produce this angiogenesis, which is some, there is a protein as well as enzyme involved in this angiogenesis so that they can produce or develop a new blood vessel. So that's basically the similarities, right? So both of them have abnormal cell growth as well as angiogenesis. Now, so when you're talking in terms of normal cell, benign, and metastatic, so basically you have a normal cell, all right? And then if the cell becomes uncontrollable, okay, become abnormally cell divide, then it will become a neoplastic. Neoplastic meaning that the cell has been transformed. So when we say a neoplastic cell, meaning that the cell has been transformed from a normal cell becoming an abnormal cell, so benign, and then if it's further accumulated, then it becomes invasive, and then it becomes metastatic. So that's where you're going to have the cancerous cell. Now, what are the factors? So it can be mutation, it can be carcinogen, it can be irradiations, it can be viruses, and also it can be due to the unknown factor as well as genetic for that reasons, right? So because of that, then you're going to have the conditions of this abnormal cell growth. Now, we are interested in terms of what are these cell growths in terms of immunology. So how does our systems, okay, how does our immune system basically deal with this abnormal cell growth? So that is the focus for our discussions. Okay. Now, before we go into immunology of this, then I need to basically make a review or at least touch a little bit about how the cell regulates. All right, this is basically just a review. Because just now we already talked, I already mentioned that cancer cell or tumor cell is a cell with a condition of abnormal cell growth, meaning that they do not know when to stop when they start divide. So basically, if you're looking at this regular cell growth, I'm talking about interphase and metaphase, basically. All right. So in a normal cell, okay, in a normal cell, basically you're going to have these three steps, three checkpoints here. All right. So now you're going to have a resting cell. So that's basically your resting cell. And then if there is a inducer meaning that it could be a growth hormones. Okay, the growth hormone basically binds to the cell receptor, then it will transmit the signal to tell the cell, okay, we need to divide. Alright, with the new cell. For the reason being, maybe the cell is already senescent, meaning that the cell is aging and going to be died. Okay, the cell dies, so you need a new cell. Or maybe because the cell damaged cell. Okay, because of the damaged cell, so you need to replace the new cell. So because of that, then you're going to receive an inducer in the form of hormones, maybe the growth hormones, to tell the cell to start dividing and replacing this aging cell or damaged cell. Now, in doing so, to replace this new cell, then you're going to have this 3 point of a checkpoint to ensure that the new cell that you are producing or that your cell is producing is going to be the right cell. So of course you do not want to produce a wrong cell. Alright? So these three checkpoints, which is basically in the interface, before the interface, alright, you're going to have this G1, and then you're going to have the G2, and then you're going to have the end phase. G1 is basically the first checkpoint before you actually go into mitosis to produce new cell. So this is during the interface. So basically what this G1 will do is basically will check out, will do the QS, if you will, okay, quality assurance, to make sure that the template that you're going to use, the DNA that you're going to use, the genetic material that you're going to use to duplicate the DNA so that it can be passed to the next generation contain no errors. So basically you're checking the starting materials. Alright? If there is any mistake, if there is any condition in the starting material which could be transferred to the next cell and then causing the problems to the next cell, it will be fixed first. Take care of the problem first. So that is the function of this G1 checkpoint, to occur to make sure there is no damage to the starting material. If it cannot be repaired, then go to apoptosis. You do not want to inherit something which is wrong. Now, if everything is right, then we go into the interface. So that's basically your basic biochemistry. Alright, your DNA will start to replicate, producing new DNA so that it can be passed to the next generations. Now, once it's completed, then that's going to be your G2 checkpoint. Basically, quality assurance of the new DNA. If the new DNA that you produce contains a mistake, once again, it needs to be repaired, then it needs to be repaired by all the necessary mechanisms. Alright? So if everything is correct, then you go proceed to the mitosis where you're going to divide, producing new daughter cell, and then go the next stage and the next stage. If there is the mistake cannot be repaired, then once again go to apoptosis. You do not want any wrong cell in the system. Alright? So once you correct this one, then you go to the last stage. So the last stage is the end stage. The end stage is basically the last checkpoint during the mitosis process. So G1 and G2 is basically during the interface. Endpoint is during the mitosis, to make sure that the chromosome is properly aligned during the metaphase. Alright, during metaphase, the chromosome is supposed to be aligned to your paired chromosome before you separate out, right? So if it is not properly aligned, correct them. Otherwise, it cannot be corrected, once again, remove. Okay? So these three checkpoints is to make sure that the cell, the new cell that will be produced to replace the aging or the damaged cell, going to be the right cell. Alright? So now the issue with tumor and cancer cell is because of this problem. G1, either G1, G2, or N. If there is any mistake, if there is any issue in the checkpoint, or if there is a condition where you bypass this checkpoint, where you're not supposed to, then that is when the cells starting to grow abnormally or do not know when to stop. So basically, they receive the information, you need to divide your cell, but they do not receive the information when to stop. Remember, our system has a limited capacity. You cannot just produce new cell whatever you want or how many you want. It has a specific capacity. Alright? So that is basically what's going on. So in the case of tumor, you're going to have a tumor or cancer. Basically, you're going to have this balance, the balance between divide and stop is off. There is no balance between receiving the signal to start divide, producing new cell, and stop when enough new cell has been produced. Is not balanced. So basically, you're going to have the on switch, if you will, okay? But you never receive, the cell never receive the off switch. And because of that, then this new cell will continuously producing new cells are becoming abnormal. Okay. So that's basically what it is. Now, one thing that you have to realize is that when you do this, okay, when you do this, or when the cell is going uncontrolled divide, they're still producing a cell proteins, basically. There is no antigens per se. Alright? So that is the problem. So even though you have a cancer, but your immune response does not respond to it. Because it is cell. It's just that it's producing more than what it's supposed to. Okay? So in terms of how this thing, or what are the possibilities that this could be wrong, is that it could be due to, like I said, the factor that can result of this situation can be many. It can be genetic, it can be radiation, it can be environmental, or it can be unknown. Alright? So basically, once again, you're going to have, this is the normal one. Alright, the normal one. Once you have this normal gatekeeper problem, then it could lead to the formations of tumors. So it could be because of the viral infections that disturb the gatekeeper, the G1, the G1, G2, as well as the N. Or you're talking in terms of mutation and radiations that affect the checkpoint, the three that we discussed before. All right. So because of that, you're gonna have a problems. The cell will not know how to divide. Now, in our system, we have a set of genes. Okay, a set of genes what we call oncogenes. Okay, which is specifically function in this regulation. There are many. Okay, the one that I showed here on the slide. These are just among the main genes that we know and understand in terms of how their involvement in the gene regulation for cell division. So these are just a few examples of this. All right. So whatever these oncogenes being disturbed, or meaning that if any of these proto-oncogene or regulatory genes, when they're not functioning properly, then we're going to have the problems of the imbalance. It's not the combination just now. Alright? So basically, you're going to have, like I said, for a normal cell, they need to receive a stimulatory pathway, meaning that, like I said, for example, growth hormone, to tell them go through the process of cell division. And then, once it's completed, then you need this inhibitory pathway, another signal to tell now is enough, shut it off. Okay? So the imbalance between these two is the one that will cause the cancer or tumor. Now, in terms of its behavior, okay, in terms of the behavior between normal cell and cancerous cell, is that number one is, like I said, normal cell, they know when to grow, when to start, know when to stop. Enough. But for the cancer cell, they're going to have uncontrollable cell division. So they do not know when to stop. Number two is that in terms of contact inhibitions, normal cells know how to be a good neighbor, but not cancerous cell. There is no contact inhibitions. Alright? So for a normal cell, when they grow, when they touch the neighboring cell, then they stop. They will go to another direction of an empty space. When there is another cell, then they stop. So at the end of the day, you're going to get only one layer of cell. But for the cancerous cell, they do not have this sense of contact inhibitions, then they just go piling up. So that's why you're going to have this multi-layer. So that's why you're going to have this mold. So basically, the mold is the accumulation, multi-layer of cell. That's why that produces this mold, or like that, on whatever on the things, for example, right? For normal cell, the differentiated cell. So basically, differentiated cell is the cell that receives a signal to do specialized cell. But for cancerous cell, they also target another differentiated cell. So meaning that even though the cell is not supposed to specialize, then they just receive the signal and then they do it anyway without any proper needs or requirements. Okay, of course, the abnormal nuclei, basically the one that I mentioned just now, that is a damage in the DNA during the replication process. All right, and this is the problematic of this cancerous cell, that it does not know, or it will not undergo apoptosis. Okay, as we mentioned just now, a normal cell, when you cannot fix them, then they will sacrifice themselves. They will not allow themselves to be accumulated. But for cancerous cell, the signal to tell them that you need to commit suicide, if you will, right, or self-suicide, basically killing yourself, is not there anymore. So that's why the cell will divide. There is no apoptosis signal anymore, or the apoptosis signal is no longer responsive. So that's why we're going to have accumulations of the cell. Now let's go to the immunological side. If immune system deal with tumor, they first have to recognize them as a foreign. But the problem is that it is a cell. Alright? So it is a cell. So it is going to be difficult for the immune response to deal with this abnormal cell. Alright? This abnormal cell. So for that reason, then the immune system would need some kind of marker in order for them to react against this abnormal cell. And luckily, whenever a cell is abnormally divided, usually there will be some variation. So this small variation, or what we call this tumor antigen, is the one that is used by our immune systems to make sure that the cell will not survive. Alright? So we are thankful for these tumor antigens. So that tumor antigen is the one that keep us from developing this tumor and finally cancer. So the process of this tumor formation, or the process of a cell going uncontrollably divided in terms of producing abnormal cell, it happens all the time, 24/7, 365 days. All right, in a year. So that means our body constantly develop this tumor cell, but we still do not develop problem because of our system, or immune system still can recognize, even though it is initially a cell, but because of these tumor antigens, then that's how our immune system can manage to deal with it and then remove from our system. Okay? Now, we are talking in terms of this now. If the cell itself has a mechanism of apoptosis, okay, to make sure that you're not producing any abnormal cell. But if the abnormal cell, like I said, they still produce, but our immune system will take care of that by the presence or recognition of this tumor antigens due to the variation, slight variations. And this tumor antigen also, it is an immunogenic, meaning that it can be developed memory. Alright? So that's how our immune system basically managed to deal with it. If you have this cell going abnormal and then produce these tumor antigens, in the same cell going into an abnormal division again, then our immune system recognize it, memorize it, and then start attacking and then remove from the system, so that you will not develop a tumor, or in that worst case is the cancer issues. Now that tumor antigens, can be either what we call a specific tumor antigens, or whether it can be associated tumor antigens. Okay, so you're going to have these two types, which is recognized by your immune system, so that your immune system can remove from the system those cells which is abnormally divided or abnormal cell. So when they are talking in terms of tumor-specific antigens or tumor-associated antigens. Now, what are the differences between these two? For the tumor-specific antigens, is basically due to it. It's because of starting from the cell itself. All right. So basically, you're going to have a mutation. So this is a very simple diagrams of these tumor antigens. So you're going to have mutations. All right. You're going to have mutations that basically mutate the cell protein a little bit. All right. And because of that, now that's considered to be foreign, right? So now we know that if the MHC, recognize a self-antigens, then it will terminate it. Okay, back to your basic immunology. So once it recognizes any normal cell or any self-protein which is being mutated, so that is the one that will be recognized as a marker and then presented to the NBC to be taken care by the acquired immunity to remove that from the system. Right? So these tumor-specific antigens, these are some examples. Okay, these are some examples of tumor-specific antigens for the different kinds of tumor as well as cancer. You have that breast cancer, you have carcinoma. Okay, so that's some example. All right. The other one is tumor-associated antigens. All right, tumor-associated antigen is basically, I don't want to say it is genetically inherited. All right, it can be have the high risk, right? But basically, the mutation is basically present, is already present in the at the embryonic level. Compared to the tumor-specific antigens, all right, compared to the tumor-specific antigens, the antigen is basically not present during or in the embryonic cell. Maybe because of the mutations once it's already gone into the adult stage. Maybe because of viral infections, right? Compare these tumor-associated antigens. So basically, they are present in the or during the embryonic cell or stage. Doesn't mean that when it presents in the embryonic stage that it will definitely become a tumor. Do not get me wrong. Okay? Sometimes that's what makes an individuals increase the chances or increase the risk of developing a tumor. So that's why whenever people screen, okay, when people screen for any tumor marker, they will say, okay, you have this tumor marker, meaning that you have a higher chance of developing a tumor. So that's what it is. Does not mean that necessarily you will develop. So I hope you understand that. All right. So it doesn't mean that you definitely going to develop, but it is present. So the chances are there. So that is the one which what we call the tumor-associated antigens. All right. So the difference between associated antigens and the specific antigens. Okay. So these are some examples. For example, overexpress, we call that of a certain. This is in the prostate cancer, right? So this PSA is basically a tumor marker. So if you have this marker, you will increase the chances of to get the tumor or the cancer, but that not means that you will get the tumor. So you get the presence there, right? So this also virus can also induce this tumor-associated antigens because of the infection itself. Okay, they are an example of hepatitis B, for example, as well as human papillomavirus. I'm going to use these two as an example where HPV basically they will interfere with one of the stimulatory pathways. So you have this stimulatory pathway. If you're talking in terms of hepatitis B, usually they will interfere with the inhibitory pathway. Okay, there are viral proteins that interfere with that pathway that results in that abnormal cell growth. Okay, abnormal cell growth. Okay, so that's basically, like I said, for tumor associated, they are usually during the presence already in the embryonic genetic level, right? Okay. So the difference, like I said, the difference between the tumor-specific and tumor-associated antigens, okay? So you're going to have expression on the tumor cell, but not the normal cell, all right? But associated antigen expressed on the tumor cell, but also on the normal cell. So that's why I say it's present in normal cell because it's already present in the embryonic, okay, present in the embryonic level or genetic level, okay? Now, how our immune system actually deal with these tumor conditions. So that will be the job of the acquired immunity. And the more is the focus or the responsibility is more for the T cell related or cellular related immunity or CFI. But Once again, when I say cellular immunity, doesn't mean that acquired immunity, or we call that humoral immunity, does not function at all. Alright? Because remember, immune system is always integrated. They will not work individually, but they also work with the others. Alright? So in terms of T cell mediated, okay, in terms of T cell mediated, so this is what we're going to have the cytotoxic T cell. Alright? Cytotoxic T cell is one of the main effector mechanism in terms of removing any cell with the presence of this tumor marker. Okay, when they are talking in terms of tumor-specific antigen or when they are talking in terms of tumor-specific antigens. Alright. But of course, whenever you want to have the CTL, you're still going to need to have the cell as a part of it. Otherwise, you're not going to receive any cytokines for the activations of the cytotoxic T cell. And the other one is, of course, you're going to need the authentication signal, which is the post-stimulatory signal as well. Alright? So, when we have all these three components, then there is these are among the what we call that effector mechanisms that will attack that tumor cell, if you will, or the cell with this tumor marker, so that to be removed from the system. So you're going to have this phagocytosis complement, what we call that complement activation that will lead to your formations. Natural killer cell, alright? Of course, you're going to have this T cell activation as well as you're going to have the one that I mentioned earlier, which is the one, the cytotoxic T cell. Now, in the case of tumor immunology, you're going to have this what we call the cross presentations as well. Now, when you're talking in terms of APC, okay, in terms of class 1 and class 2, usually, class 2 is for T helper cell. You're going to need class 1, MSC class 1, that will be interacting and then activating, producing the cytotoxic T cell that attacking whatever target that you have. But in the tumor immunology, now you're going to have the cross presentation. Sometimes even class 2 can be recognized to help the system to deal with this tumor, to deal with the cells that tumor. Okay, so you're going to have this class 1 and class 2 basically they are working together, and then not really specifically only for class 1 or class 2, but they work together so that you can have this, the best in terms of trying to deal with this tumor marker or cell with this tumor. So that's the reason why, like I said, our cell basically is very susceptible, so they will develop this tumor or potentially becoming a tumor cell 24/7, 365 days a year. But since you have the immune system to deal with that, then that's why you do not develop a tumor, or that's why you do not develop cancer. Right? So, like I said, the rest of the mechanism, like I said, that should be familiar to you now. When I say neutrophil cell, then you know what is this. When I say ABCC, that's one of the examples of the effector mechanism. You know what is ABCC is all about. Right? Now, if cancer cells are immunogenic, why cancer cell or tumor cells such a big problem? Okay, one thing is that because just now, because it is part of you, it is part of it's a cell antigen, so you will not recognize it as a threat. In fact, you will develop a tolerance, right? So even though you have this, what we call that tumor-specific or the tumor-associated antigens, they are not a strong immunity. Once again, coming back to the issue of it's starting from you. It is you. Basically, it is a cell antigen. So therefore, it's not a very good immunogenic. It's just a mutation. So you're going to have some mutations that basically differentiate. So you have variations of your protein or cell antigen. So that's one thing. The other one is that tumor immune suppressant block host response. So that's also, if I'm talking especially in terms of tumor that's involved virally induced. Okay? We will see in a minute an example of that. So since it's not a strong immunogenic, so then the response is also going to be not as quick. Okay, it's a slow response. So when you have a slow response, then allow the cell to divide faster. So you're going to have a play, what do you call that, play catching up, but it's going to be slow for you. So then, of course, the cell will have to divide, have the opportunity to divide even more, okay, and faster, right? Not a strong one related back to the immunogenic, cannot be enhanced also because it's not a strong immunogenic. So that is the reason why it may not be received as a threat rather than tolerate against the cancer cell or the tumor cell. Now, the tumor cell itself is not, will also make things worse when the tumor cell also have a capability of trying to avoid or evade the immune response itself. And this is one example where they down-regulate the class 1 MHC. Alright? So an example is, like I said, this one is an example of adenovirus, where adenovirus is considered as one of the oncogenic virus that can induce, alright, tumor formations. And the way it's induced tumor formation is that by also there are a few mechanisms utilized by the virus, either interfering with the stimulatory or the inhibition pathway, as well as reducing the MHC class 1. So without the MHC class 1, basically you're not going to have any strong response or activation for the cytotoxic T cell. The same thing, you're talking in terms of MHC class 2 as well. And for that one, it also affects the cross-presentation, because cross-presentation gives us an advantage, additional advantage to help with the cancerous potential tumor cell and cancer cell. But when you interfere with MHC class expressions, then you will also influence the ability for cross-presentations. Okay? And the other one is how they what we call that, evade the response is by this post-stimulatory, lacking post-stimulatory, meaning that do not produce this authentication signal. Remember, when we discuss about T cell activation, you're going to need primary interaction, MHC class 1, MHC class 1 with your T cell receptor, as well as you're going to need second signal and third signal. That is what we call the authentication signal, before you get activations of the T cell or T lymphocyte. Alright? So that's why I say our immune system is very good in terms of regulations. Alright? Now, when you interfere with this secondary or authentication signal, then you're not going to get any activation of the T lymphocyte. Alright? For that reason, then you're electing this T cell mediated or cellular mediated. That's another way of how this tumor actually invade our system. Alright, also they will block this, okay, they will block this T cytotoxic response. For example, ADCC and natural killer cell, if you remember how does it action, it will depend on the FC receptor, right? It will bind, FC receptor will bind to the FC on the cytotoxic T cell and natural killer cell, and finally you will activate the enzymes, right? So now you will block that interaction. So because of that, then you're not going to have any interaction that leads to the inactivations or basically the natural killer cell and ADCC will not work because you prevent the binding of the FC part that will bind to the receptor on the target cell. Okay? So that's how you block. So this is basically how this tumor are capable of evade our immune response. Alright, so when the tumor successfully evade our immune response, then let's allow or give the tumor a possibility to develop or accumulate the cells. So that's when you can start to see the tumor formations and the finally might lead to the cancerous cell. Alright, so overall, when you're talking in terms of evasion, it can evade by attacking the T cell itself. In the case of, remember, one of them is prevent the apoptosis. Okay, so you prevent the apoptosis, or whether you're talking in terms of making it more tolerable, reduce the MHC. Then you're not going to see a strong T cell activations. Okay, suppress the T cell regulations, ignorance, as well as the one that I mentioned just now, which is cross presentations. You reduce it. Basically, you will affect the cross-presentation as well. All right? So all these things is basically the one for how this tumor is actually can evade our immune response, even though our immune response can recognize this tumor, what do you call it, this tumor marker present on our cells. Okay? Now, the last part is basically we're talking in terms of the cancer, in terms of the vaccine. All right? One thing is that the same thing, this is related to, I think I showed last time before, why there is no HIV vaccine. I think I mentioned in my COVID lecture. Right? So there's a reason why there is no HIV vaccine. And why there is a COVID vaccine in less than 1 year. The same thing, why there is no vaccine for cancer for the past 100 years. The same thing, because of that. It is not the same situation. In the case of cancer, number one is that it has to differentiate. That is the main issue in terms of developing a cancer vaccine. But you have to differentiate between self and non-self. Number one. Number two is that even though there is a tumor antigen, it's not a strong immunogenic. Even you manage to produce a vaccine, the vaccine will not be as effective as it is, or as you expect. Alright, that's two. And the third one, which is not in there, is that cancer is basically, it is a multifactorial condition or disease. Maybe the development of the cancer is not only by one factor. There are multiple factors, at least 2 or 3 factors that contribute to the development of the disease. Now, if you have a vaccine to one factor, what about the other factor? Alright, so that's why it is difficult to develop a vaccine against a cancer. Okay? So, what the current vaccine, what we call a tumor vaccine, is basically the idea here is that to help our immune system to deal with this cancer. So that's what they call it in the tumor vaccine development, okay, or cancer vaccine development. The focus is what we call immune therapy. We know that in the case of cancer, the problem is that our immune system cannot recognize it properly. So now if you can make the immune system recognize it, that is the cancer cell, and that will be the way to go. So a lot of them is basically focusing on the APC, so the APC can present it well. Or you are talking in terms of making the stimulations. Okay, remember about the one that I mentioned this time, one way of a cancer cell avoid is by interfering with, reduce this in this class presentation, reduce the post-stimulatory release signal. So these are the ones that focus in terms of vaccine. How does you increase the ability of our immune response to deal with the cancer? So that is the focus, right? So for the current vaccine that we have, it's not really against the cancer, but against the factor of it. One example of vaccine that is available right now is against cervical cancer, okay, HPV. But the vaccine is not against the cervical cancer, but against the virus, the human papilloma virus. Right, so that's the one. So hopefully, when we have an immune against human papilloma virus, then it will not, what we call that, the infection will not cause a serious problem that leads to the cervical cancer. Right, so once again, to deal with or to have an immunity against the cancer itself is very difficult. Right? Or you have this therapeutic. So basically, this is where you're going to have to increase your immune modulations. Okay, immune modulation. So intensify or arguments or what do you call that? Intensify or increase, enhance the ability of the immune response to recognize, okay, a cancerous cell or a tumor cell. So that's how, or the approach right now that people are trying to develop when you're talking in terms of tumor vaccine. Okay. And like I said, one of them is enhancing this APC, because you are talking, when you're talking in terms of cancer cell, it's basically internal or indigenous. So when indigenous, so that means you need to present it. And what are the individual that are responsible for this, or the cell which is responsible for this is your dendritic cell or your APC. Alright, so that's what the focus is, how you want to introduce, presented this tumor-specific cell or tumor-associated antigens well so that it can be recognized. So that's why we have this approach, is basically try to enhance the APC or antigen presenting cell ability to present the antigen cell. Okay, present the antigen cell. Of course, we may have also right now we have these cytokine therapies. All right, because we know cytokine is needed. You need cytokine so that it can stimulate or induce your immune response. Remember, again, coming back to what I said earlier, there are ability of certain tumor that can induce all these post-stimulatory and everything. So you need that additional, what you call that, help, so that it can stimulate the necessary response against the cancer cell. Okay, so you're going to have these different kind of chemotherapy. So all these things, what we call immune therapy, immune modulation therapy against cancer. All right. So basically, like I said, the bottom line is that you try to help the immune system to recognize better, to recognize better the cancerous cell or the tumor cell, so that the immune system can detect and then finally remove it from the system. Okay. So, like I said, there are many. Okay, there are many. Whether you are talking in terms of in the developmental stages, or whether you already been used. For example, interferon gamma is a very common cytokine given, right, to prevent proliferation of cancer cells. Right. So these are some examples. There are other cytokines that is targeting the angiogenesis. Remember. Angiogenesis is one of the factors that's needed by the abnormal cell. Okay, if you can prevent angiogenesis, basically you will prevent the formation of the blood vessels. So because of that, the cell will start to death. Right? And some other what we call that approach targeting just to make sure that the cancer cell will be contaminated, or basically will be taken care in terms of not presenting problems first. Right? So now that's basically how the current condition or the current development in terms of tumor vaccine, right? Okay. And lastly, thank you and the very best of luck, because today is my last day. Starting next week, Dr. Guru Reza will take over on me. All right, and go.